The United States of America officially admitted that the 7th generation fighter jet has entered the real-world verification phase. They didn't disclose the model number. They didn't show the exterior. Only one sentence. It can end a war without opening the weapons bay. What does that mean? A fully AI-controlled combat platform can strike, leave the battle zone, and even change the enemy's data chain before the other side realizes it's there. Not only is it stealthy, it can even fool enemy radar and satellites, creating false target images and disrupting the entire airspace. This is not an air superiority fighter, nor is it a bomber, but an intelligent war corps that integrates command, jamming, assault, and surveillance. It doesn't even need human pilots. The AI decision-making system adjusts the attack logic in real time according to the evolution of the battlefield. The fastest response time is 0.003 seconds. The military has not detailed its deployment location.
Я ухожу. Я сделал все, что мог. Мне на смену приходит новое поколение, поколение тех, кто может сделать больше и лучше. В соответствии с Конституцией, уходя в отставку, я подписал указ о возложении обязанностей президента России на председателя правительства Владимира Владимировича Путина. Прощаясь, я хочу сказать каждому из вас: будьте счастливы. Вы заслужили счастье.
Everyone, do you know why A4 paper is designed to be this size? 297 millimeters by 210 millimeters? Why is A4 paper made this big? Why not 300 millimeters? Why is this a math problem? Let me show you. This is an A4 sheet, right? If you double it, after doubling it, everyone, what size does it become? It turns into A3 paper. For A3 paper, its length to width ratio is still 297 to 210. Wasn't the original ratio 297 to 210? After doubling, it becomes A3 size. But the length to width ratio is still 297 to 210. Isn't that amazing? What's even more remarkable is that if you double the size of A3 again, if you go one size up and double it again, you'll find that it becomes A2 size. This A2 paper, its length to width ratio is still 297 to 210. Isn't that incredible? If you use any other numbers, it just doesn't work. Only 297 and 210 are reasonable. Now, if you double the size of A2 again, if you enlarge it one more time, you'll notice something. Its length to width ratio is still 297 to 210. It just becomes A1 size. And if you go down from A1, if you double it again, I can't fit it on the blackboard anymore. If you double it again, it becomes a 0 size. A 0, its length to width ratio is still 297 to 210. But what's the most important thing? What's the most amazing thing? This A0 size, its area is exactly 1 square meter. That's right, the area of A0 is exactly 1 square meter. It's that incredible. And most importantly, what is 297 divided by 210? Everyone, what is it? It's 1.414, which is what? The square root of 2. Only with this ratio can it achieve such perfection. No matter how you cut or fold that 1 square meter of a 0, the ratio always stays the same. So, you see, studying mathematics really is useful, everyone.
International Space Station took over a decade to complete. We've got to remember, the station isn't just aimlessly floating in space. It's going incredibly fast, about 20 times the speed of sound here on Earth. It orbits the Earth once every 90 minutes. Here's the front of the station. It always travels in this direction. So this is forward and aft, port and starboard, and then there's zenith pointing away from the Earth, and nadir, pointing towards the Earth. These terms are part of the regular vocabulary of an astronaut. We'll be using them a little bit throughout this video. This is what the completed station looks like. The only part that the astronauts can live in are the pressurized modules. When I say module, I'm referring to one of these cylindrical pieces of the space station. It has air to breathe, comfortable living conditions, and protects the astronauts from the vacuum of space. Each module has one or more berthing ports that can be connected to other parts of the station. Sometimes these are referred to as docking ports, but if we're being specific, it is a berthing port because the joining module or spacecraft must be assisted by use of a robotic arm. There are two main sections to the station: the Russian orbital segment, these are modules from Russia, and the United States orbital segment. These are modules from the United States, Europe, and Japan. You can see how the modules on each side look just a little bit different. On the US side, the modules are connected by the Common Berthing Mechanism, or CBM for short. There are two different sides to this, the active side and the passive side. Once these are brought together, latches pull them in close, and then there are 16 bolts to firmly mate them together. The space in between is called the vestibule. This will be pressurized with air. This process takes a few hours. Then the hatch is opened, some of the hardware is removed, and connections are made in between the modules, which includes oxygen, power, data, and water. Once finalized, there is a white protective barrier put in place. The astronauts can now move freely in between the modules. The Common Berthing Mechanism is used for modules that are permanently attached together, like the Harmony and Destiny modules. They can also be used for visiting spacecraft such as the SpaceX Cargo Dragon. The Russian side of the station uses a different docking mechanism that is not compatible with CBM. We need some way to connect to the different mechanisms. This is kind of like taking a power plug from the United States and bringing it over to Europe. It's not compatible with the wall plug. What do we need? An adapter. It's the same concept on the space station, but on a larger scale. Two different mechanisms, so we need an adapter in between. This is called the pressurized mating adapter.